Friends, today we are going to discuss a problem which says that there is a block on the table of length 1 meter and it is moved by a force and it has velocity u as initial velocity, and when it comes to the another edge of the table it fall off. First it was on the right edge of the table, and then it was on the left hand edge of the table, and then it fall off. So the question says that ki whether the object has wheel or not. What says? Is the object has wheel or not? Or not? It is the question. So what we will do here? Here we will let a case one, that is we will let that it has wheel. Let the object has wheel. Then we will see that it is a table and there is a particle object, and its center of mass is moving its velocity v, and the body is rotating by angular velocity omega. Then I will use here equation of motion, that is s is equals to ut plus half acm into t square. Acm is what? Acm is the acceleration of center of mass. Okay, then s is given as 1 meter as I given here, and ut plus half acm into t square. Then we got here ut is equals to 1 minus half acm t square. acm t square. We got here first equation, and secondly we got v square equals to u square plus 2as, and here we get u square and this v square minus u square equals to 2a, and we will use the equation v is equals to u plus at, and here we will squaring both if we will square both sides, here we will get v square, and here we will get u square plus a square t square plus 2uat. Then if we uh, subtract by u square on both sides, we will get v square minus u square equals to a square t square plus 2uat, and here we will put the value of this as 2a equals to a square t square plus 2uat. Here a will be cancelled out, then we get 2 minus 2ut is equals to a into t square. Then we will get here 1 minus ut is equals to a t square. Then we'll put here the value of ut, then we will get here u equal 2 minus 1 plus a t square by 2 is equals to a t square by 2, a t square. And here we will cancel. Here we get 1 equals to 1. And so friends, if we get in mathematics 1 equal to 1, that means let you have equation here something, that is y equals to f of x, and the value of y, if you solve the function f of x, you get the value 1 equals to 1 or 2 equals to 2. Then it means that the thing that you applied is correct, and it satisfies all and it is satisfied by all values. So that means our assumption was correct. But we have to take second case. What will happen if we take the case that it has no wheel? Then we let here case 2, that it is simply block which has no wheel and it is moving with u velocity and it comes here. Then what will be here, that in this question, in this part this block, if it will move, if friction will act on it. So friends, in this question is based on real life. That means it is not a virtual condition or like that. It is based on real life, and we know that in real life friction can be variable. What we know that? We know that in real life friction is variable. What? Friction is variable. That means if it will move, it kinetic friction will apply. But in this case it was in pure rolling condition, so here was static friction. That means v equals to r omega. And if in the condition or at the place here it violates the rule v equals to r omega, that means it was not following rolling motion, then it will sometime that means rotate. So friction will always support it. That means we know that friction always opposes relative motion. So in this question the friction will be variable, then we will not able to use here equation of motion in this case. That means acceleration of center of mass will be variable. That means acceleration is changing with time. And but in this case this was supported by a case of rolling, and sometime it was rotating. That means, and we got the answer this. And here it violates because it is not in this case also it is variable, but rolling is supporting the variable friction is supporting rolling. That's why it is correct. Thank you.